Let's say you've got a dyno chart posted on the internet and you would like to extract the data. How would you do it? You could contact the owner of the car or the vendor who produced it and ask them for the files. But what if you don't know the owner? What if you don't know the vendor? Or what if the owner or the vendor just simply refuse to give it to you? Could it be possible to extract the data without their help? In this tutorial, I'm going to show how to do exactly that. I'm going to show how to extract the data from a Dyno file posted on the internet and convert it to an Excel spreadsheet. This technique only takes 15 or 20 minutes from start to finish. But when you're done, you'll have the exact data as if you had the Dyno file itself. So let's get started. First, we want to remove all of the background material and all of the colors from the graphics file. Next, we want to convert it to black and white so that all that we have left is just a black and white image. Next, we're going to export that data to a Microsoft Excel spreadsheet. Once it's in Excel format, we're going to read it in and regraph it. Finally, when we're done, we're going to compare it against the original. In the first part of this demo, I'm going to show how to use this procedure on a Dyno file that we have the source to. It'll be a DynoJet DRF file. So first, what we're going to do is we're going to open up one of the Dyno files in my collection, and in this case, we're going to be interested in extracting the boost data. To help this process go a little bit faster, the DynoJet software has an option to convert it to black and white. So I'm going to try that already. I'm going to convert it to black and white, and I'm going to export the graph into black and white. Just so we can compare it when we're done with the actual data, we're also going to export the data. Next, what we're going to do is we're going to bring that file up in our graphics program, and in this case I'm using Corel Paintshop Pro. Okay. Now we have our file and we have it in straight black and white format. The first thing I'm going to do is going to look a little bit strange, but in order to remove all of the background material, we're just going to start deleting it. We want to make sure that all of our colors are nothing but black and white. This whole process only takes a few minutes. After just 2 or 3 minutes, all we're left with is just the boost graph and a couple of little XY, crosshatches from the original graphing. So what we want to do is to take that out is we're going to start zooming in a little bit, and then we're going to get a little paintbrush, and then we're just going to start erasing these things. Okay? Keep this up until we are done. And when we zoom back out, we can see that we have the entire boost graph without any artifacts. Now, as one last check, we're going to see how many colors there are. If we're still in black and white, there should be 2 colors, just as we can see. Okay, so the next step of the process is to take this image and extract the data from it. We're going to use a program called ImageMagick to do this. And what ImageMagick will do will be to scan this image and giving the XY coordinates of every color in it. Once we get the XY coordinates of every black and white pixel, we're just going to throw away the white pixels and we're only going to keep the black ones. The next thing we need to do is import this data into Microsoft Excel. When we first open our Boost demo spreadsheet, there's a few fields that we have to fill out before we can import the data. If you look up at the very top row here, the canvas size. The canvas size is the size of the original graph. This DynoJet graph, if you look down in the bottom right hand corner, you can see image 1280 by 801. The next thing we need to put is the overlay size. Sometimes the overlay may be a different size than the canvas. In our case, the overlay is the same size, but we could have a situation where the overlay was a different size. Like in this case, the overlay is 1121 by 586. And finally, the overlay could start at a different location. In the case that there's an offset where the overlay starts, meaning it doesn't start at the origin at 0, 0, we need to put those values in here. 2 more things we need to do. We need to scale the axes so that we know where the RPMs start and where the boost starts. So we're going to go back to our graph and we're going to see that we're going to get an exact pixel location for this 2.5, that's 2500 RPMs, and 8.5, that's our 8,500 RPM. So the first thing we do, back to our spreadsheet, let's put in 2,500 and 8,500. Over here in column J is going to be the pixel location of those coordinates on the screen. So let's zoom in quite a bit so that we can get a good look. We're going to go over here, and if we hover our mouse over that 2.5 and look at the x coordinate, we can see that it's at 111. Then let's go all the way over to 85, and if we do the same thing, hover our little mouse over the coordinate at 85, we can see 1153. Those are the two values that we're going to put in this field right here, 111 by 1153. The next one we're going to do is the boost. Same idea, but this time the values are over here on the right hand column of the screen. The first one with a number is 2, but we can see that there's 4 divisions between 2 and 4. So let's go down to 1, and when we hover our mouse over the 1 psi boost, we can see that the y coordinate is 709. That's the value that we want to put in for the first y coordinate corresponding to 1 psi. So we can see we have 1 psi here at 709. The last one that we're going to put in is the upper value. We're going to go all the way up. We can see the last number on the screen here is 16 psi. We're going to go up one more at 17. Look at the y coordinate, it's 7. So we're going to come back to our spreadsheet, and we can see that 17 psi is pixel location 77. So that's what we need to do to set up the graph for it to scale correctly. We're finally ready to import the data that we exported with ImageMagick. If you remember, that data is just XY coordinates. So we're going to open it up as a text file in Microsoft Excel. So we're going to open up Boost Data, Boost Demo, and you'll see that a wizard comes up on the screen. This is delimited data. And what we're going to do is, if you look down in the bottom section here, we can see that it's like X comma Y and then space equals. So we're going to call this delimited data, and we're going to choose comma and space as a delimiter and click Finish. All we care about is the XY data. So let's highlight columns D, C, D, E, and F and delete them. Last thing we want to do is, you'll notice that it's in reverse order. We want to sort it. We want to sort it back in its original order so that it goes from 0 to the highest number, not the highest to the lowest. So we're going to sort it. Column A, smallest to largest. Now what we're going to do is we're just going to highlight the whole thing. We're going to copy it with Control C, come back to our Boost Demo, paste it right starting at row 6, and voila, we have data on the screen. This is a graphical representation of the data that we pulled out of the image. Next, what we're going to do is we're going to overlay that with the actual DynoJet data to see how they compare right on top of each other. I've included the DynoJet data in the spreadsheet in a tab called DynoJet Data. To make it a little bit easier to see the accuracy of this technique, I've thickened the line of the boost data that we extracted from the graphics file. Next, I'm going to import the DynoJet data and overlay it right on top of here. I overlaid the DynoJet data on top of the graph that we generated using this technique. As you can see from this image, the black line is our generated data, and the red line that overlays on top of it is a perfect match in every way. Now that I've demonstrated the ability to extract the Dyno data out of a file posted on the internet, let's see how it compares to the actual data. I've already prepared a comparison chart in the next tab over on the spreadsheet called Comparison. For all intents and purposes, we've perfectly extracted the data from the Dyno chart. In the next demo, I will show how to use the same technique to tackle a much more complicated problem. In this Dyno chart below, there's 7 different Dyno files, and once again, I'm only interested in extracting out the boost data. Now that we've shown how accurate this process can be, I will attempt to extract only the boost data out of this bottom graph to create a consolidated boost log of all of these dyno runs. Thank you for watching.